So in this case, we are going to consider as a continuation from the recap that we have been working with. Now we have got the compound angle identities, which is a major aspect as we are actually seeing this for the first time for those who are starting their grade 12. This will be the first time for you to be dueling with these identities because previously in your grade 11 you have been working with the reduction concept and all of those aspects that we managed to have as a recap. So nothing is going to change, guys. Nothing is going to change on this. We are going to use them as they were before. All this part of your special angles, use it as it was before. It's an application that has to be continued with. That is why we had to look into that part in the first place. So in our case, we have the compound angle identities, which are taken when two angles are being combined together. So it's a combination here of two angles. A combination of two angles being added or subtracted one from the other. We are not going to look into the proof of this in our case. We need the application. And after that, we are going to look into the proof later on after you have known how to use this. All right. It is something that you are given in the formula sheet. That's the advantage of our compound angles. So whenever two angles are combined together, alpha and angle beta, in our case, we're going to use the angle alpha and what? The angle beta. So we have got our alpha and the angle beta. So in our case, when these angles are being combined together, maybe it's X and Y, it's A and B, whatever that you're given. So I want us to get used to what we have in our formula sheet. So I'm going to be using alpha and what and beta so that we get used to that. All right. If we put X and Y tomorrow, you put A and B, then most of you guys will end up even having confusion. So I'm just going to maintain that as it is given in your formula sheet. So these angles, they can be added together, alpha plus beta. Or you can have alpha minus beta. For an example, let's consider we have got two different angles, 50 and 20 degrees. It is the cos of 50 plus 20 degrees like this. This here does not mean you must expand cos to the angle that you're given, then cos to the angle that you're given. No, that is totally wrong. That is totally wrong. Remember, if we add these two, 50 plus 20, we are going to obtain 70 degrees. So it's cos 70. If we were to simplify this, the cos of 70 degrees, I want you to see something here. Cos of 70 degrees. This is 0.32. It is not the same as the answer that you're going to get when you had to expand cos multiplying the 50 degrees, then you add cos multiplying the 20 degrees. This is totally wrong. If you are going to do that, you take your cos here, cos 50 degrees. You add to the cos of what? 20 degrees. 1.58, which is totally different from what we obtained before when it was cos 70 or cos 50 plus what? 50 plus 20 degrees in the bracket as it is given here. This is totally different. So it means that expansion is not. So how do we expand? That is the identity concept. So identities, guys, know them the same way that you know other identities, to say the tan of x is equal to sine of x over cos of x. The way that you are singing those identities, the cos squared of x plus the sine squared of x, giving you a 1. It is the same way that you must do even for the double angle identities. So it follows that if we have got a sine of alpha plus beta, two angles added together, take note, alpha and beta, this is the identity that you're going to have, which is sine alpha cos beta. So it's sine of the angle alpha, then cos of beta, then we add, take note, this time cos of alpha, then sine of beta. So it's an interchange here, sine alpha cos beta cos. All right. Same for subtraction. If it is a minus, it's going to be also a minus there. Same expansion, sine cos, cos sine. Sine alpha, sine what? Sine beta. Minus cos alpha, sine beta. So this is what you are going to have if you are working or you're dealing with what? The identity for a sine. Whereas a cos, if it is alpha plus beta, we're going to have the product cos alpha cos beta of the given angles, but the sign changes. It was a plus, now a minus. The sign there changes, and its product sine sine of these two angles, sine alpha, sine beta. Same when it is a negative, the sign changes to a positive. Cos alpha, cos beta, sine alpha, sine beta. Same concept as before, only that the sign changes. So guys, this is just a direct application. What we're trying to say is that if I am given to expand using the same concept, let's say I'm given the cos of 45 degrees minus 30 degrees. There we have two angles. Let's say this is our alpha, this is our beta. The identity here is telling us that we are supposed to expand this as what? Cos alpha minus beta. Cos alpha, cos beta. Alpha and beta, which are the angles. So that's cos 45 degrees, cos 30 degrees. The sign changes now. It was a minus, changes to a plus. So whatever that you're going to have there, sign changes to a plus. Sine alpha, sine beta of those angles, sine 45, sine 30 degrees, sine sine. So it's cos cos, sine sine. You have expanded. Then you can use whatever that is equivalent there from what we learned to remember their special angles, this and that. So we cannot run away from those now. You see, we have to apply when it is applicable. That is the case. So it's a vice versa to a condition where we might be given from this side. You must be able to rewrite in that manner. Okay, what am I trying to say? They can give us something like this, cos 70 degrees, cos 50 degrees. Or let us just say, I just need one angle that we're going to have 70 minus, okay, let's just use 40 here. All right, minus, or you can even use the plus, no problem, plus sine 70 degrees, sine 40 degrees. I want us to see something here. They gave us this. Expanded. So what we must look into is, are these angles the same? 70 degrees. 70 degrees. 40 degrees. 40 degrees as well. So it is the same thing as we are given cos alpha, cos beta plus the sine of what? Alpha there and sine of beta. Where was this taken from? Cos alpha, cos beta plus sine alpha, sine beta. It was taken from this. So you can rewrite cos of what? It was supposed to be alpha minus beta, alpha minus beta, alpha minus beta. What is your alpha here? 70. Minus, what is your beta? 40 degrees. You see, we can rewrite it back and simplify what is inside of the bracket to a single angle now, giving us a single trig. 70 minus 40, which is what? Which is 30 degrees, which we can now use its equivalent from our special angles. The cos of 30, we have it, so we can even write its equivalent, square root of 3 over 2. So you see how to play around with this. So in our class, it is how to play around with your double angle. I mean, with your compound angle, which can give us double angle later on. Going to look into that one in our next class. So I want us to know how to play around with this. All right. So questions can be given. Let us just look into examples. Like I said, guys, we are not going to look into the proofs. We are going to do a class that is meant for that one. I'm going to make proofs, how to prove, how to actually end up with these formulas that you see here, all of them. So it's another class that you're going to look as a separate class after you've done examples and questions, learn a lot of questions so that it will be easier for you to realize that in our proof. All right, we are given in this case to simplify or evaluate whatever that you're given there. That's the first question we want to simplify the sine of 20 degrees cos of 40 degrees plus the cos of 20 degrees, the sine of what? 40 degrees. That's what we have. Given this, we are supposed to look into the identity which it was taken from. Where is this coming from? This is part of our compound angle. Sine, cos, another part cos, sine. Where was it taken from? All right. Are these angles the same? 20 degrees. Here is 20 degrees. This is 40 degrees. This is 40 degrees. Meaning to say we are back to these because they have two angles that are corresponding. Alpha to alpha. All right. When it is alpha to the alpha there, beta to beta. That is the concept. So we look into sine cos, expansion, which gives us sine cos. Which one is it? With a positive. Sine cos with a positive. So you're here. Sine alpha, cos beta. So there are two angles that are different. Alpha, beta. Alpha, beta, like that. So this was supposed to be written, was supposed to be from here. So we rewrite from where it is taken from. That's the sine of what? Alpha, which is 20 degrees, plus beta, which is what? 40 degrees. That's what we were supposed to have here. Alpha plus what? Plus beta. So we are going to combine it. This is going to give us the sine of what? 20 plus 40, that's 60 degrees. So are you going to leave it like that? No, because we know this from our special angles. We dealt with this. The sine of 60 degrees is what? Square root of 3 over 2. So we are going to have this in a simplest form. Square root of 3 over 2. Simplification. You've simplified using the compound angle identity concept. All right, let's look into another question. Again, it is to simplify. All right, let's consider the second one. Simplify the cos of 50 degrees, cos 140 degrees, minus the sine of 130 degrees. All right, sine of 220 degrees. So if we look into our question, we are going to notice something different. The angles, they are different. Like here we needed something like Sam to say this is 50, this is 50. This is 140, this is 140. But in our case, it's not. It's not the same. What happened? What actually? Because it's not giving us what we expect. But one thing ensure that this is part of our compound angle identities is the expansion thereafter. Cos, cos, sine, sine. We know this expansion is under our compound here. Cos to cos, sine, sine. Cos, cos, sine, sine. So as of the sine, do not consider this one because maybe it might change. We do not know what's going to happen as we are to simplify these to make sure that they are the same. So as we saw that it is under a compound angle identity from either cos alpha plus beta or cos alpha minus beta. What we are going to do now is to make sure that these angles, they correspond. The 50, the 130. The 140, the 220. How can we do that? Because we are supposed to have the same angle. We cannot use the formula if those angles are different. So we try to use the reduction concept. Remember our reduction from our previous class. So we go back there. Try to figure out what actually happened. All right. Let's save these in the simplest form as we do consider our reduction is rewriting angles that are greater than 90 degrees to angles that are less than 90 degrees from 0 less than what? 90 degrees. All right. So the first one, cos 50, it is actually in simplest form. There's nothing that we can do there. So that's cos 50 degrees. Okay. The cos of 140 degrees, this one, it's more than 90 degrees. More than 90. So we have to reduce this one. Where exactly do we have this angle? Remember from our previous class when we dealt with those positive angles, 140, we expect that one to lie in the what? In the second quadrant, where it is written as 180 minus theta in the second quadrant. So it was supposed to be cos of 180 degrees minus theta. What is that theta that we must subtract to get 140? So it's simply 180 minus 140, which is what? 40 degrees. So this was supposed to be written. Okay, let me just write it. Cos of what? 180 degrees minus 40 degrees. This is what we have. All right. In the second quadrant, we are just rewriting as an acute, having that acute, so that we can reduce it. Minus, as it is, the sine of 130 degrees, 130 again, more than 90 degrees. lies in which quadrant? In the second quadrant. 130 is less than 180, remember? In the second quadrant, this is the same quadrant where we write our angles as what? 180 degrees minus theta, remember? In the second quadrant. So this is what you're going to have. 180 minus what? So it is the sine of 180 degrees minus what are we supposed to subtract to get 130 from 180? So it's 180 minus what? 50 degrees. If you subtract 50 degrees here, we are going to get 130. Then 220 is more than what? 180 degrees, but less than 270. So it lies in the third quadrant where the angle must be written as 180 plus theta. So it must be 180 degrees plus our theta, the acute angle. Which acute angle must we add here to give us 220? So it's simply 220 minus 180, which is 40 degrees. So if we add 40 degrees here on this one, we are going to get 220. So let's then reduce our angles, our trig ratios that you're given here to the simplest. Cos 50, still in simplest form, there's no effect here. Cos 50 times cos 180 minus 40. We are now rewriting as what? A trig of the acute angle. Theta, theta, theta as in terms of what? Theta. So 180 minus theta in the second quadrant, that is the quadrant for sine. Remember from the cast concept. All right, we talked about this guys, cast. So thus a cos there is what? Negative. Since we are talking about sine, cos there is a negative. So that's negative cos of what? Acute angle theta, which is 40 degrees. It is a negative there. Minus the sine of 180 degrees minus 50. The acute angle there, 50. So the sine is going to be written as what? The sine of the acute angle, since the positive, guys, in the second quadrant, 180 minus. So it's sine of 150. The minus here, guys, do not, let me put the bracket so that we do not confuse each other here. The minus is the one that we had from the formula. This one, it was already part of our formula. All right. We rewrite also the sine of 180 degrees plus 40 degrees here. The acute angle being 40. Which quadrant are we talking about? 180 plus. The third. This is the quadrant for tan. So sine there is a negative. So that's going to be a negative sine of the acute angle 40 degrees. So this is it. We can simplify further. Negative here times the positive is going to be negative cos 50 degrees cos 40 degrees. Remember, that's a product. We simplify this whole part. Here there is a negative already here on our formula, then the negative on the sine of 40 degrees. So that's negative times negative. It was going to be a positive. All right, so that's positive sine of 50, sine of what? 40 degrees, like this. All right, so this is where we are. It's going to be a condition where we have got a negative in our case. So in our case, there's a negative, so it's going to be positive, but this one being a negative. So if we check now the layout here, we are back to the layout that we wanted of having the angles being the same, like 50 here on cos, then 50 here. All right, this is 40 here, this is also a 40, so that we have got alpha and beta. But as we have these, guys, we can see that The layout does not match to what we had above because of this negative on cos. The cos has to be positive, as we can see. The part of cos, it's positive, this one. It is the part of a sign which can be negative. It can be negative, it can be positive. Not this one of a cos. Are you saying that the cos is positive, guys, here? The cos is positive. So let's make that cos to be positive. How is that possible? To say this whole part of a cos is what? Negative. As we can see, there's a negative, but we want it to be a positive. How do we do that? We simply factor out the negative. We factorize or factor out a negative. Negative. So by factorizing or factoring out a negative, thus we are going to have this as a positive. So it's going to be positive cos 50 degrees, cos 40 degrees as a single term as it is. But as we factored the negative, here there was a positive. So positive divided by a negative is going to give us a negative. Positive to a negative. So that will be negative sine of what? 50 degrees sine of 40 degrees. So this is what we are going to have. What we are trying to have here, guys, is to properly see our cos and our sine there, separated by what? A certain sign which can be positive or negative. So this part of a sign here can be under a negative. The sign there can be negative, can be positive. But here, avoid that to be a negative. You must factor out the negative. So we are back to the application of our identity. As we have our alpha 50 degrees, same here. Our beta 40 degrees, same here. Which identity are we going to use? Which is cos to cos minus sine sine. So that is here. Cos alpha, cos beta minus sine alpha, sine beta is supposed to be cos alpha plus what? Plus beta. Cos alpha plus what? Plus beta. That is where it is taken from. So here it's going to be negative as it is, but we must have cos of what? Alpha minus beta. Where we say this is our alpha, guys, this is our beta, alpha what? Beta. So that's 50. Sorry, alpha plus here, we need the one with plus beta. So that's plus the beta, which is what? 40 degrees, just like that. So this is what you are going to have at the end. And simplifying this 50 and 40 degrees combined together, that's going to be what? 90 degrees. You add. So we do know, guys, the cos of 90 is what? That's 0. The cos of what? Cos of 90 degrees. That's what? That's a 0. So that was going to give us negative 0, negative 0. There's nothing like that. It's just what? It's just a 0. So you see the application of this. We must consider each and every step. The angles were not the same, which is very true from what we're given. So do not panic now on the exam. Say, oh, no, these angles are not the same. Remember reduction. That is why we started with this part. It is also playing its role there. They can even give us negative angles. Remember also your reduction for negative angles. It can be a condition where even the co-function concept has to be used because there's a change that can happen from one of the two. So do revise all these basics. All the basics are to be considered as part of your revision. All right, let us consider another part of question. Still trying to apply or to use our compound angle identities. Sometimes they might give us questions. All right, let's just consider still our simplification. We need this part of expansion from the expanded part. Then we're going to look into other questions later on. All right, let's say we are given the cos of 3a times the cos of a. So realizing that it is a compound angle is the most important. Realizing that and that expansion, because most of you guys, you won't be able to tell under exam. Now you end up having a lot of calculations. So trigonometry is one of the easiest topics as it is direct, but the moment you complicate it, then it becomes something else. But the advantage of it, in whatever way you choose to work it in a simpler way or you choose to work it in a complicated way, still you're going to get your answers. That's the advantage of what? Trigonometry at the end of the day. All right. We are given cos times a cos, sine times a sine. We have this simplification, cos to a cos, sine to a sine. Are these angles the same? That is what you're supposed to ask yourself. 3a, this is same, 3a. This is a, this is a. So meaning to say, guys, this one is half done. There is no need for us to change anything. It's just rewriting that is going to be the cos of what? When added, it means it was taken from alpha minus beta. So that's supposed to be cos alpha minus beta. What is our alpha? What is our beta? Just like that. Our alpha, 3a, and our beta is what is a. So we were going to subtract. So 3 minus a, 3a minus a, this is just 1. So 3 minus 1 is what is 2. So it's going to be cos of what? Of 2a. So cos 2a, this one, we're going to talk about it as a special identity on its own in another class, which is referred as the double angle. From compound angles, double angles can be produced. So we're going to talk about that one later on. So this is it. We're done. It's a single trig. You're asked to simplify maybe to a single trig. Then in that case, you know that you'll be done. All right. So this is how these questions, in most cases, might be given as, and sometimes they can be a condition where you are asked even to prove your identities. All right. So many things, guys. Prove. Let's say we are given something like this. Prove that. All right. The sign of a plus b minus, all right, it's all right, it's a plus, so it's a minus, so it's a product. This one, it's a product. Sine of what? Of a minus b is equal to, all right, so here you see now as I'm trying to write this now, supposed to be sine of what? A minus b, the sine of a minus b, like this. All right. This here is equal to the sine squared of a minus the sine squared of what? Of b, which is just written as a sine only. All right. Okay. Prove that these two are actually the same. Okay, no problem. If we are to consider the proof, we can consider the side. Remember, it's not the first time working with these questions under a proof. We just understand we need to choose a side that we can prove from. In my case, the left-hand side is more complicated and it has these identities, sine of a plus b, alpha plus beta, we have something like that. Also a minus b, alpha minus b, or beta there, we have an expansion for that. So it would be wise enough for us to choose from the left-hand side, as we have got expansion on that one. So choosing the left-hand side, where I have got the sine of a plus b times the sine of a minus b. I'm supposed to show that it is supposed to give me exactly what I have on the right hand side. All right, so sine a plus b is just, guys, the same as it is alpha plus beta. This is just a plus b, so it's going to be sine alpha cos beta. So that's sine a cos b. Sine of it changes, so it's sine of a, then cos of what? Of b. So it changes there. Sine, cos. The plus as it is, also the plus, we're going to have it. But now we're going to have cos of alpha, sine, which is just interchanging here now to say it was sine alpha, now cos alpha. So it was sine A, now cos of A. It was cos B, now sine of what? Sine of B. Just like that. So we have expanded the first part using its equivalent identity. But remember, this is a product. What we got from the sine of A plus B is to be multiplied to what we are going to obtain from sine of A minus B, which is sine of alpha minus beta. There is no change from what we had before. It's only the negative, negative, negative as it is. So it is just going to be like what we had before. The sine of what? The sine of A, the cos of what? The cos of B. Negative this time. The cos of A as it is, the sine of what? The sine of B as it is. Guys, are we realizing something here, that we have a product, two brackets, but in these two brackets, there's something that we cannot. Sine A cos B. Sine A cos B. It's a single thing. It's a single, just like a single term. It's a single term. The cos of A, the sine of B. It's a single term again. Cos of A, sine of B. It's a single term. Separated, plus here minus. What is it that we understand about this? A difference of what? 2 squares. Here, back to a difference of 2 squares. Remember your difference of 2 squares concept, that the a squared minus b squared was taken from two brackets of a minus b into a plus b. So in our case, we have this a minus b into a plus b, the brackets. Where were these brackets taken from? Vice versa, a squared minus b squared, where this is our a, this is our b, this is our a, this is our b. So when we say a squared, I mean the whole sine of A cos of what? Of B, being squared. Being squared. So it's going to be sine squared. Cos squared. Okay? Minus B squared. When I say B, I mean the whole part here representing cos A, sine B. So if it is cos A, the sine of B, the whole part, has to be raised to the power of 2. So it's going to be cos squared. Cos squared of A, sine squared. Sine squared of what? Of B. Each and every term expanded like that. Cos squared. All right. Where did I get this? It's B here. It's B. Cos squared B, isn't it? Cos squared B. sine squared A, cos squared B. Cos squared A, sine squared B. So let's correct that part. All right. Anyways, with this part here, we need to simplify. But our answer, remember it was a proof, this one. So the proof now, we can go back and check how is that answer given. If we check properly on our answer here, because we're asked to prove that this is supposed to give us here sine squared A minus sine squared B. It is just in terms of sine only. We only have sine on our answer there. But here, as we expanded and simplified, we can see there's a cos. There's a cos. So we have to get rid of the cos so that it remains in terms of a sine. Remember now our Pythagorean identity from the cos squared of x added to the sine squared of x, giving us a 1. So when it is a cos squared, it's going to be 1 minus sine squared of x. That's going to give us a cos squared. When it is a sine squared, the same thing. But in our case, we do not need to change a sign. We need to change a cos. So thus, we are going to replace these with their equivalent identities. Cos squared of B, cos squared of what? Of A. With their equivalent identities. All right, so meaning to say, the sign remains as it is because it's part of your answer. Your answer must be in terms of a sign. So the cos squared, as it is 1 minus sine squared, therefore it's going to be 1 minus the sine squared of what? Of B. Okay? Minus, we are going to change the cos squared of A in that case. So this is going to be written as 1 minus sine squared of what? Of A times sine squared of B. This is where we are. We do not have a cos this time. It is just a sign that we have. At least to be certain that our answer can be in accordance, because we are almost there. It's only a sign that we have. Let's expand these brackets. As we can see, there are brackets to be expanded. The first bracket of 1 minus sine squared of B has to be expanded, and here 1 minus sine squared of A. All right, so if we are to expand, that was going to give us what? Sine squared, we distribute times 1. That is the sine squared of A. Sine squared multiplies the sine squared of B. So it was going to be sine squared. Need the sine first. There's a minus there. Minus sine squared of A. Sine squared of what? Of B. We are done with the first bracket. The second bracket has to be expanded. But take note, there is a minus sine B squared. So it's supposed to be like this, minus sine squared of B into 1 minus sine squared A, so that you properly understand what is happening here. So it's negative sine B times 1, which is negative sine squared of B. Okay? Negative sine squared of B times negative sine squared of A. So negative, negative, that was going to give us a positive. So that's positive. I'm just going to start with the sine squared A, sine squared of A, sine squared of what? Of B. All right, or you can just write sine squared B times this. It's one and the same. Or just start with the sine squared of A, so that we just match to this one the way that it is given there. So we managed to expand our brackets. Then if they are like terms, collect your like terms. Are there any like terms. Consider those like terms. In our case, we do have this part of minus, this part sine squared A, sine squared B, sine squared A, sine squared B, this one. These are like terms, exactly the same thing. So this is same as we've got -1 plus 1. So -1 plus 1, guys, this was going to simply cancel. So you'll be left with sine squared of A, sine squared of A minus this one, the sine squared of what? The sine squared of B. So you'll be left with that part. This is how to attempt these typical questions. And as we saw, our answer, it was in terms of a sine only, and this is what we have, sine only. Let's check. This is exactly sine squared A minus sine squared B. So this is exactly what we have, which is our right-hand side. So that's how you play around with your identities. That's how you play around with your identities. We have proved that it is exactly the same as our right hand side. So our left hand side is equal to the right hand side. You have managed to prove using the compound angle identities. There are so many questions on proofs to prove, so many. You just need to work out as many questions as you can. It's revision time. If you're in grade 12, there is no time for sleeping, guys. It's time for revision. Everything has to be known from our grade 10 mathematics, grade 11 mathematics, the previous stages. So you have a lot of things to put in mind as a revision. So do revise a lot of question papers because you have done most of the basics before. So the more question papers that you revise, the more that you get the idea. There is nothing like I am in grade 12. No, you are not in grade 12. You are revising what you have done before. Grade 12 is revision of what you have done before. So if you just work out the syllabus according to your ATP, you just check, okay, my ATP is like this. I'm just going to revise compound angles. I do not revise these things that I did before. You're fooling yourself. Because at the end of the day, those aspects will be asked from your previous grades. So make sure that each and every aspect is known to the fullest. All right. Another question, let us consider this one as the last part of our questions. We're going to add more as we move on. So that is for now. Let us just add one more example to use in our simplification. We are being asked to simplify from our special angles the sine of 75 degrees. Simplify. Or they'll ask you to evaluate this. Evaluate or simplify this, whatever that you're given, without using a calculator. Without using a calculator. So the question is, how can we evaluate this? Because our calculator was simply going to give us a straightforward answer, sine 75 degrees. We have the answer. We have the answer. But they are saying, do not use it. But we must get that answer without using a calculator. All right. Remember your special angles. Whenever you ask this type of a question and they are numerical values, 75 degrees is a numerical value. So in that case, go back to your special angles. Look for two angles that can be combined to give us 75. So the sine of 75 degrees from our special angles, because there is a concept under compound angles which separates two angles. This is there. Is it by addition or by subtraction? So we look into that from our special angles. Which two angles can we use to get 75? All right, as part of our special angles, remember there is a 45-degree angle and also a 30-degree angle under these. So 45 and 30, there is something about this. If you add, you're going to get 75. Let's look into that. So this is the same as the sine of what? The sine of 45. We say the two angles, 45 and what? 45 and 30 degrees being added together. We add them together. Adding these two angles together under the trig of a sine as it is here makes us to apply the compound angle concept, as these are two angles separated, alpha and what? And beta. Alpha and beta. This is our concept. So if you had an identity which you used before with alpha and beta, guys, sine of what? Alpha plus beta, giving us sine alpha cos beta. It must be the same thing. This is our alpha. This is our beta. So it was supposed to give us what? Sine alpha, sine 45 degrees. Cos of beta, cos of what? 30 degrees. Plus, the way it was a plus, also a plus here, plus the cos. This time you start with a cos. You started with sine, this time you start with a cos. Of the same angle alpha, of the same angle 45 degrees. The sine this time of what? The same angle beta 30 degrees. You have expanded by following. You follow identities. These are proven mathematical statements. They've been proved to be correct, to be correct in every aspect where you have that condition. So you expand not by your knowledge, but by the knowledge of the identity. You follow it. You are inside the identity. Not to say you want the identity to follow what you think. No. You think according to the identity. Once you do that, you are good to answer any question. Anyone. So as we have expanded using the compound angle formula or identity, we are done. Its use that is its use here. We have applied it. But are we going to leave it because we have applied it because we're in grade 12? So you say we just use compound angle. No, remember your grade 11 now, where you had special angles. So you go back now, insert each its equivalent. The sine of 45 degrees is what? We talked about this in our introduction, 1 over square root of 2, or you can take this one, the simplified one that you can also have on your calculator. So I'm going to take the one before it's simplified. Let's see the layout here. Since it's a product, let me just take before it's simplified. We'll see later on if it's going to be simplified or not. So this is, or we can even simplify whatever that you want. So this is 1 over square root of 2. 1 over square root of 2 times the cos of 30 degrees from our triangle, the cos of 30. This is square root of 3 over 2. Square root of 3 over 2 plus the cos of 45 degrees. Remember, cos and sine are the same. 1 over the square root of 2 times the sine of 30 degrees, which is what? 1 over 2. All right, we dealt with this one before, guys. That's why I'm just rushing here. So this is where we are. We can see something about the denominators. The denominators here are actually the same. So we can maintain that one, the part of our denominator, like this is square root of. We can rationalize our denominator. We can just, guys, it's up to you. You can simplify as it is here, meaning to say it was going to be 1 times square root of 3, which is the square root of 3 over 2 times this is 2 square root of 2 plus 1 times 1, which is 1 over square root of 2 times 2 is 2 square root of 2. This is what I was trying to say. The denominators are the same. So looking into this, you can simply add the numerators together because of that denominator concept. So that will be square root of 3 plus 1 as it is over what? Over 2 square root of 2. Remember, if you're given A over B plus C over B, just add A plus C over B. The denominator is the same. But as we have got this as our answer, yes, we can leave it as it is. But this is not in simplest form, so you can also do consider to rationalize the denominator. So you see now, that's the disadvantage of taking it from the way it's not yet simplified. If you used the simplified part, it was going to be easier because there will be no rationalizing later on. But anyways, I'm going to show you guys, no problem. Let me just finish this one. If you are to rationalize, some of you guys, you can actually leave it here. They'll actually give you marks there, but just learn to rationalize just in case, these examiners, guys, they might just, them. So let us rationalize here. The square root of 3 plus 1 over 2 square root of 2. Remember your grade 11 mathematics, the denominator is the one that is important. You multiply throughout by the denominator, the numerator, and the denominator. Thus, 2 square root of 2 is going to multiply the numerator here, 2 square root of 2 times the square root of 3. So square root of 2 times the square root of 3 is going to give us what? Square root of 6. So that's 2 square root of 6. 2 square root of 2 is going to multiply 1. So that's 2 square root of 2. Everything over what? If you multiply 2 times 2, that's a 4. And here, square root of 2 times the square root of 2, that's a 2. Remember from our laws of sets, square root of a times square root of a is what? Is a. So square root of 2 times square root of 2 is going to give us a 2. So that is what you are going to have in our case. We can see the 2 here is common in the numerator. So we can factor that 2. And thus we are going to obtain square root of 6 plus square root of 2, everything over 4 times 2, or you can just leave it as 4 times 2 and cancel this 2 here. So that is what you're going to have, square root of 6 plus square root of 2 over what? Over 4. Exactly the same answer that we got before on our calculator here. Exactly the same answer that we got. Or you can even factor out the square root of 2 is still one and the same. So this is, guys, is simplification. This is what I was saying, guys. It's not about grade 12. It's about the previous grades. Rationalizing of the denominator, simplifying these sets. So we could have avoided that, rationalizing here at that stage here. So this is what I'm trying to say. Instead, okay, let me take it here. Instead, on your expansion here, when you had this part, that's another way that we could have expanded. We could have just used the sign of 45 in its simplest form. In its simplest form, it is what? 1 over square root of 2. Remember, it is the same as square root of 2 over 2 from the sine of 45. Remember this? And also the cos. So taking this in simplest form, it is going to give us what? The square root of 2 over 2 times The cos of 30, this part is not going to change. Cos of 30, we have it in simplest form already, square root of 3 over 2, square root of 3 over 2 plus the cos of 45, remember, it is the same as the sine of 45. We want to use the simplest form, remember? The sine of 30, we talked about this. This is 1 over 2. So using this in simplest form was going to make it easier for our question because there is no need for you to rationalize the denominator. The denominator is already a rational number. You do not rationalize the numerator. Remember, it is the denominator. So let us multiply the numerator to the numerator concept. Square root of 2 times square root of 3. That was going to give us square root of 6. Remember, square root of A times the square root of B. If these numbers are under the square root, they can also be multiplied under the square root 2 times 3, which is going to give us 6. So that's square root of 6. The denominator to the denominator, 2 times 2, that's a 4. All right, let's move on to the second part of the fraction. We have square root of 2 times 1. Remember, guys, just going to remain as it is when multiplied by 1. 2 times 2, that's a 4. So the denominators are the same, just like the previous case. Whenever this happens, you simply combine the numerators under that denominator that you're given. In the denominator of 4, combine the numerators together. Square root of 6 plus square root of 2 as it is, just as it is there. This is exactly what we got. So working with a simplified answer makes it better. So that's why now we say, if we use that simplified, because it is the same thing as you have on your calculator, the sine of 45 degrees, square root of 2 over 2. So there's nothing now special about this because you can also just get it on your calculator as it is. So as for me, guys, I would choose to work with a simplified. Yes, if you understand the rationalizing of the denominators, it's fine, as we ended up having at the end. Your answers will be the same at the end of the day. So it is in your hands. Are you going to choose this expansion or the other way around? But all in all, that is what we have under our compound angle identities. So guys, identities, once you deal with identities, in fact, guys, the whole process of our mathematics, it's all about revision. There's no topic that you're going to say this one is an easy go. Yes, it is like that, but for it to be easy, you have to study it in as much as you can. So let's do revise as many questions as we can where we do not understand. That is why we've got the community section. Let's communicate under our community section and also the comment section. All right, for those who want to comment, you can also comment, but let's utilize in as much as we can our community section. Send your questions there, communicate. Let us know what exactly is it that you need in your revisions as you are preparing yourselves for the exams that are ahead of time.